Hello, algebra students. Welcome to Chapter 9, Section 1. If you have not yet written your name on your notes, please do that. Class, I guess you would be Hour 1, probably. And what we're talking about in this particular chapter, Chapter 9, Section 1, are quadratic graphs and the properties that go with them. All right, quick review from Chapter 8. What you do need to know is that quadratic, highest power is 2 on the variable. That's from Chapter 8 when we were factoring and we used quadratic, cubic, and those things. Highest power is 2. Quadratic have some really interesting functions and some properties to them. Highest power is 2, for example, x to the power of 2. This particular graph here is a special graph called a parent function. We'll just call it the parent. And the parent, this equation is y is equal to x squared. If we were to create a chart and plot these points, this is the graph that would come out. The parent function is what we will compare other graphs to. For example, I might give you another graph and I will say, is it wider or is it more narrow or does it move up or down the y-axis compared to this one? There are some properties about this that we've got to know. The first word that you've got to know is this word, parabola. Okay, a parabola is basically this kind of cup-shaped thing, this cup-shaped graph, and it can open up or down. The one that you're looking at on the paper goes up, all right? And a parabola that opens up is said to have a minimum or a lowest point. For example, right here. Okay, this point right here is a minimum. Okay, now the reason it's a minimum is if you consider the values of y, this is the lowest point and there are no existing points underneath this place where it turns from going down to up. So that's a minimum value. It's the lowest value on that particular point. All right, if we had a graph a parabola that opened down, I'll sketch one. You have a little more space on your paper, I think, than I do. So if you could sketch, something that looks like that. If we had that kind of graph going downward, and we had this point right here, this would be called a maximum. I'll just put max right here, but right here, it's a maximum. It's the highest point. Okay, so every parabola, every quadratic is going to have a minimum value or a maximum value, okay, depending on if it goes up or down. Now here's another word you have to know, vertex. That vertex is the minimum or the maximum point. Okay, so it's really important that you add this, get all the stuff I'm writing down, has got to be in your notes and you've got to study it. That is the vertex of that parabola. Okay, and here's the vertex of the downward parabola right there. So that place, that minimum or maximum point, is the vertex. Okay, another really important thing to know that we're going to talk about a lot is this thing called an axis of symmetry. All parabolas have one. All parabolas have an axis of symmetry. I will do it in red over here. Okay. On your notes, sketch. Now you've got to do it right on the line. Through the vertex, you would sketch a dotted line, make it dotted to make it clear, a dashed line rather, that this line right here, notice it splits the parabola into two, it splits it symmetrically into two similar sides, whereas like if you had a mirror and you set it right there, you would see the shape of the parabola. This line is called the axis of symmetry. Axis of symmetry. And it's important whenever we're dealing with quadratics and parabolas that you identify the vertex and the line going through that vertex, its axis of symmetry. It will make our life much easier if you will do that first thing. And we'll learn how to do that, complicated ones a little bit later. We'll see some easy ones today. So moving on down your page, you see this, and let's identify some of the things we just talked about in this first example right here where it says problem. This says, what is the vertex of the graph below? Is it a minimum or a maximum? Well, this is the vertex right here, this point. Okay, so first thing I want to identify is the vertex. And its vertex is the ordered pair for this value. Now here's my origin. Okay, so if I'm going to identify this ordered pair, it's -1, -2, -3, so the x value is -3. Okay, and then I go +2, I go up 2, so the vertex is -3, 2. Now, is this vertex, is that a minimum point or a maximum point? Well, recall that the parabola is going down, so that is the highest value of y, which is 2. So this is a maximum point. A maximum. My writer here does not cooperate as good as my one at school. And then the third thing I want you to notice that is not mentioned in this particular problem, but I want to go ahead and get in the habit of you doing it. Would you draw a dashed line again through the vertex, making clear that it's dashed? And this is the axis of symmetry. Okay, the axis of symmetry. Now the axis of symmetry is actually a line. It's a line that goes through the vertex. So at this particular line, it's all values where x is -3. So the axis of symmetry, the equation, we say, is x equal -3. All right, so you will have to identify the equation for the axis of symmetry, which is x equals 3. That line right there, x equals -3. X equals -3. That line is what splits it in half. Really valuable for us. So, right here, they tell us the answers we just said. The graph opens down. Okay, you're looking for the highest point, the maximum. -3, 2 is the vertex, and the axis of symmetry is x equals -3. All right, well, moving on down my page, then, at the very bottom, let's do this. Let's identify the vertex, tell whether it's a maximum, a minimum, or maximum, and identify the equation. Please add this on your paper for instructions. I want us to do this today, even though it'll pop up later in the chapter. Let's just get used to dealing with it now and identify the equation for the axis of symmetry. You can probably fit yours on better than I can. I don't have quite as much space as you. Okay, so number 1. So let's do those 3 things. So let's do this. Identify the vertex. That's going to be number 1 for each of them. Tell whether it's a minimum or a maximum. Number 2 and 3. Identify the equation. So divide this into 3. We got 3 questions here. So 1, 2, 3. All right, vertex. So the vertex is the point of the minimum maximum. So for this one, the vertex is right here. 1, 2, 3. So the x value is 3. Here's my origin. Start there. Goes up 1, 3, 1. Right? Question number 2, is it a minimum or maximum? It's a minimum because it's the lowest value. Okay, let's draw the axis through the vertex. So the equation for the axis of symmetry, number 3, is x equals 3. Right there. All right, so here's what I'm going to ask you to do. I'm going to ask you to pause the video and try answering number 2 and 3, and then I will come right back with the answers here in just a moment. So hit pause now and see if you can do 1, 2, and 3, then restart the video and I'll pop up the answers here in a second. There it is. All right, if you're back, how did you do? Okay, there's the vertex of number 2 is 1. Here's the origin, so it's 1, then -6. It's a minimum value because it opens upward. The equation for the axis of symmetry is x is equal to 1. So if you're wondering, gosh, looks like that that equation number matches the x number. Yes, it will. It always will. Okay, the axis of symmetry always goes through the vertex, the x value, and all those x values are the same value as that value of the vertex. So it's really pretty simple. It's just understanding that it's there. Okay, so vertex for the last one, -3, went to the left 3, -1. It's a maximum because it opens down, and the equation is x equals -3. Okay, that gets us through the first page. I'm going to stop this one now and go on to page 2 as we get into how to create these graphs here in the next 2 pages. So I'm going to stop this one and continue in a moment with next.